Good morning, class. This is Sohar Bakhtiari, your math instructor. How are you all doing today? How's everyone doing today?
Good. Thank you.
Thank you.
I'm glad to hear that. I'm glad that you can hear me. Just to go over some due dates. This Sunday at 11:59 p.m. Please make sure you cover complete homework on sections 1718, quiz 4, and then the 10th of this month. You need to complete also test 1 review and test 1. Okay, so February 7th, homework on sections 1718 and quiz 4. And February 10th, test 1 review and test 1. And again, this is all in my math lab, okay? So what I want to do today is go over some questions, review section 1.7 with you all. I'll put some problems on the whiteboard. You try them first, please, and then we'll do it together, okay? So let's look at our first problem. Write the equation for the tangent line to the graph of y equals x times square root of 2x plus 3 at point 3 and 9. Okay, so I'm pretty sure most of you know what to do here. So what I'm going to give you is the equation of the line in case you forgot. And you go ahead and work this problem out. I'm going to help you with one more step, okay? Is that you need to rewrite it. Okay, there you go. Your chance. You do it first, and then we'll do it together. I'll give you a few minutes. You try it first. So you need to plug in the x1 to y1, and then you also have to find m at x equals 3. Plug that in, and then write the equation. Any questions, please ask. And you all know, what is m? How do you find the m, folks? Do you know that? Do you remember how to find the m? What is the m?
The slope.
Which is to do what?
The derivative, and then you plug in x.
Correct. The derivative at x equals 3. Exactly right. Okay. Go ahead. You continue, please. Okay, so these are your assignments due coming up, the 7th and the 10th. All right, so what rule are you applying to do the derivative?
The chain rule?
But before you do the chain rule, this is times, right? So you'll do the product rule, and then within the product rule, you have the chain. Okay, so let's look at that. Y prime equals x prime times 2x plus 3 to the 1/2 plus x times 2x plus 3 to the 1/2 prime. Okay, so I wrote out the product rule. Now in here, when you're priming this, is the chain rule. Okay, so let's continue with this. Y prime equals derivative of x is what? Help me, folks. What is derivative of x?
1.
1 times 2x plus 3 to the 1/3. I'm sorry, 1/2 plus x times. Now let's do the chain rule here. All right. Could you tell me what the chain rule for that is, please? Come on, folks.
1/2
Go on.
2x plus 3 to the 1/2 minus 1.
Very good. Times
2x.
plus 3 primed, correct?
Yeah.
Or won't they just be x?
So y prime is equal to just cube root of 2x plus 3. And here I have x times 1/2 2x plus 3 to the -1/2. And what is derivative of 2x plus 3?
2.
So 2. So y prime equals, let's simplify that one more step, cube root of 2x plus 3. I don't know why I'm writing cube root. I apologize. That should be a square root. It should be a square root. This is power 1/2. Here, the 2.5 will multiply. And then I'll just rewrite this whole thing. X is going to be on the top. The 2x plus 3 to the power 1/2 comes down, which becomes the square root of 2x plus 3. And we'll evaluate this when x is 3. So let's go ahead and put 3 in there. 2 times 3 is 6 plus 3 is 9. Square root of that will be a 3. Plus 3 over 2 times 3 plus 3. So that's 3 over 3, which is just a 1. And if you add these two, the slope y prime is 4. Any questions on how I got that 4, folks?
No.
So let's go ahead and do this equation. Y minus y1 is 9. M is 4. X minus x1 is 3. So y minus 9 is equal to 4x minus 12. You add 9 to both sides, and that is your equation. Okay, so that's your answer. Any questions? So did you all, mainly why I did this problem is because you already know how to do the equation. That's not what I was testing you on. The reason why I did this is on the derivative part, is to see that it's the product rule first, and then within the product rule, you are applying the chain rule. Any questions on this problem? All right, let's look at the next one. Okay, so this is all review of section 1.7. Let's say I give you y equals u cubed minus 7u squared, where u equals x squared plus 3. Find dy dx. So what you've seen here is y is a function of u, but then u is a function of x. So what should I do first to make y a function of x? Because that's what it's saying. It's telling you here. Okay, I'll tell you what this means. This means differentiate y with respect to x. So y is not a function of x. It's a function of u, but then u itself is given as x squared plus 3. How can you change y as a function of x? Can you tell me that? Replace each u that you have in here with x squared plus 3. So now your y is a function of x. You should be able to do the derivative at this point. Okay, so I'll let you do the derivative part, and let's see what you're getting for your answer. All right, so any questions on what I did, how I got this part here, and why I did that? Any questions on that, folks? Because it's asking me to take derivative of y with respect to x. But y is not a function of x, so I need to make that substitution, replace u's with x squared plus 3 to turn y into a function which has x in it. Now I can do the dy dx, okay? So go ahead and apply the rules and take derivative of these two pieces and tell me what you're getting for your final answer. All right, so I'm waiting for you to complete that, please. Questions, folks. Ask questions, okay?
I have a question. Why is it worded the way you wrote that down? Why do they say with respect to X?
Because your variable in the bottom is an x, that's what it means. Dx means derivative with respect to x. That dx in the bottom, it tells you which variable you should be differentiating with respect to. And so it's a dx here that means with respect to yes.
Okay, thank you.
If I had said dy du, then I can just go ahead and straight differentiate that, come up with 3u squared minus 14u, and I'm done. But here it's asking you with respect to x, okay? So we need to make that substitution.
Thank you.
You're welcome. So I believe that both of these are chain rule, are they not? So the first one will be 3 x squared plus 3 to the power of 3 minus 1 times x squared plus 3 combined. That's the first one. And then minus. Second one's also a chain rule, so that would be 7 times 2 x squared plus 3 to the power 2 minus 1 times x squared plus 3 combined. So now we need to prime these. And what is derivative of x squared plus 3?
2x.
Thank you. So our dy dx is 6x x squared plus 3 squared. So how did I get the 6x? I did 3 times the 2x, okay? And then x squared plus 3 to the second power. So that's my first term. 2 times 7 is 14 times the 2x, so that gives me 28x. And then x squared plus 3 to just the first power. All right, now this is the part that you need to pay attention. Sometimes they might just tell you leave it in that form, do not simplify, but most of these should be simplified. So what you need to do is factor. So 6 and 28, they have a 2 in common. Then you have x in both. And then you also have x squared plus 3 in both. So if I factored out 2x x squared plus 3 from this first term, I will have a 3 and an x squared plus 3 left. How? See, the 6 divides by 2 gives you a 3. X divides by X cancels out. And if you divide X squared plus 3 to the power of 2 by X squared plus 3 to the power of 1, 2 minus 1 gives you a 1. Now let's factor 2x x squared plus 3 from the second term. Again, 28 divided by 2 is 14. X into x is canceled. X squared plus 3, x squared plus 3 is canceled. So the second term just gives you a negative 14. And then if you simplify that, that's a 2x, x squared plus 3. Remove the parentheses, combine the like terms, so that would be 3x squared. 3 times 3 is 9. 9 minus 14 is negative 5. And that is my final answer. Any questions? Any questions with the factoring part? Did you all understand this?
Where did you get 5 in the end?
Okay, so I'm going to do this in a different color, okay? I took that 3, timed it in here, distributed the 3 here. So 3 times x squared is 3x squared. 3 times 3 is 9. And then I did 9 minus 14. That's how I got negative 5.
Okay, thank you.
You're welcome. All right, now let's do this next one. I'm going to do it right here. Leave this problem on the board in case you want to ask me questions. Let's do this one here. Go ahead, do this problem for me, please. Just raise to the third power, okay? Pay attention to that cube up there. Find the derivative.
Okay.
I remember we did one like this on Monday. Do you remember what rules would you apply to do the derivative here?
The quotient rule.
Which one would you do first before quotient?
Our rule?
No, what's the other name? This one is the chain first. The book also calls it the extended power rule, but it is the chain rule. And then within the chain rule, you'll have a quotient. Okay, so I'm going to get this started. So the chain rule will be 3, 2x, x squared plus 1 to the power of 3 minus 1, and then times by 2x over x squared plus 1 prime. See, so that whole thing that you have here is your chain rule. But now when you're differentiating this part is the quotient rule. All right, so go ahead and complete this problem. please. I'm waiting for you to do that quotient rule, and then I will simplify the final result. So section 1.8 will do some examples. It is just higher order derivatives. That means you're going to be taking not only derivative of a function one time, but you're going to take it the second time, the third time, the second time, the third time, and so forth. So it's higher order derivatives, differentiated twice, differentiated 3 times, and so forth. Okay, so we'll look at some of those. Basically, all the rules of derivatives you've already done. Okay, so it's the chain. We started with a simple power rule, and we had the constant rule, we had the product rule, we had the quotient rule, and then we had this chain rule, okay, or extended power rule. So you've got all 5 rules done. Now, section 1.8 just tells you, okay, apply these rules again, but differentiate it twice, differentiate it 3 times, okay? So the same thing you're going to be repeating. Depends on how many times you're asked to differentiate. Okay, so let's do the quotient rule. Derivative of the numerator is just a 2 times the denominator minus the numerator times what is derivative of x squared plus 1?
2x.
X.
Thank you. And it's over the denominator squared. Okay, so I have y prime equals 3. Now this fraction here, I'm going to write it as 2x squared over x squared plus 1 squared. Now, why did I power each one separate? Because see, I have x plus 1 squared in the bottom here. So I can simplify it. Now, on the top here, let's do this in red, okay? So you have 2x squared plus 2, and you distribute the 2. And then if you multiply these two here, will be minus 4x squared. So if you combine those like terms on the top, it will be negative 2x squared plus 2. And then you got x squared plus 1 squared. Now I can rewrite all of this. Again, there's a whole bunch of stuff that you can do here. See that 2x squared? You can rewrite that as 4x squared. All right, so your final answer now, pay attention. 3 times 4, so that's 12. X squared with negative 2x squared plus 2. And the denominator is multiplying these two will be x squared plus 1 to the 4th. The 2 powers 2's add, and it equals the 4th. So I'm good with that as my final answer. You don't really need to do anything else with that. All right, so if you have a power that's sitting out here, the 3, then you would have to use a chain rule after that quotient rule. If you didn't have that power here, then it's just a plain quotient. So let's look at this next example, okay? Any questions on either of these examples that's on the whiteboard?
I actually have a question. On my math lab, if it would ask us to simplify something like that, how would we do it?
You just do it like I did, right? What do you mean by how I would do that?
Like if they wanted us to simplify it for like we put that in it, marked it wrong, and said simplify more, how would we simplify that anymore?
If you were to simplify more, the one last step that you would have to do is this. See this right here? You can take out a 2 from that. So that will give you negative x squared plus 1. And then you will multiply that 2 with that 12 and make that a 24.
Yeah, my math lab really likes to change up what they expect out of you as far as the format for the end product.
Yeah, so what I'm saying is, I think I've said it a few times and I'm going to repeat it again, okay? Please, if you feel like your answer is correct, my math lab is not giving you credit for that. Take a screenshot, send it to me as an attachment. I'll look at it and I'll give you credit if you are correct. Okay, so you can list either one of those two as your answer. It's acceptable. So yes, my math lab is a little picky. My math lab doesn't like the way you answer certain things different way than what they expect. It will mark you wrong. But like I said, if you strongly believe that your answer is correct and they're marking you wrong, sometimes you do put right answers and it still marks you wrong. I've had that issue before. So take a screenshot and email me that picture as an attachment, okay? And also be very specific. Where is that problem from? Is it homework? Is it quiz? Homework 7, quiz 4. So I'll go in and I'll look at it and I'll give you credit. Okay, I don't have any problems with that. So it's your credit. You deserve it. So you feel like you did it right and it's marking you wrong, email me, folks. I don't have any problems. I'll give you the credit. All right, so let's do one more problem from this section 1.7. And that would be y equals 7x cubed over 4 minus 9x to the 5th power. Find y prime. Okay, so I am not giving you any hint. Not saying anything. You are on your own this one, folks. I'll give you a few minutes. Try it, please. So would one of you tell me what rule are you applying? Or anybody?
Quotient rule,
I'm sorry?
the quotient and
Yes.
rule.
Yes. The quotient and then the chain rule. Correct. So let's do that. Derivative of, okay, so I'm going to write here, okay, so you would remember quotient. Because see, each one has a separate power. I don't have power over the entire thing like the previous example. Okay, that's the difference between the two. And then in there, you'll have the extended power rule or the chain rule. So let's do that. What is derivative of 7x cubed? 21x squared times the denominator minus 7x cubed times. All right, now I am not going to do this. You are helping me, okay? How do I differentiate? What is the derivative for 4 minus 9x to the 5th power? Go ahead.
5, 4 minus 9x to the 5th minus 1 times 4x minus 9 differentiated.
Very good. Over 4 minus 9x to the 5th squared. All right, so let's do this simplifying part now. So it's 21x squared, 4 minus 9x to the 5th, minus 7x cubed. In the bracket, you get 5, 4 minus 9x to the 4th. And if I differentiate 4 minus 9x, it just gives me a negative 9 over 4 minus 9x to the power of 5 to the power of 2 will give me power 10. Those two multiply, okay? This is your power rule. Now, let's simplify it a little bit more in terms of clearing this whole thing that's a mess. So it's 21x squared times 4 minus 9x to the 5th. All right, so let's look at this. I need your help, okay? So here I have 7 times 5, and then times the negative 9. And I'm getting negative 315 for the x cubed to the 4 minus 9x to the 4th over 4 minus 9x to the 10th. All right, so my question is,
I have a question. What did you do with the negative 9 at the end?
I multiplied, I took the 7, negative 7, I multiplied it by 5, and I multiplied it by negative 9. I multiplied the three numbers together. And that's how I ended up. Oh, this should be a positive. I apologize. I'm glad you brought that up. This is how I got the positive 315. Okay, so negative 7 times 5 was negative 35. And then I timed it by negative 9. It gave me a positive 315. Any other questions so far? Okay, so now let's look. I need to simplify it, okay? Now, your question's going to be, how do I enter that in MyMathLab? So I've got 21 on the top and 315. They have 21 in common. I have x squared and x cubed. That has x squared in common. And then I also have 4 minus 9x, 5 and 4. So it's always the smaller as your common factor. So let's factor out 21 x squared, 4 minus 9x to the fourth from these two terms. The first one's just going to give me 4 minus 9x. Because 21 divided by 21 is cancel. X squared divided by x squared is cancel. If I did power 5 divided by power 4, I get one more. Now let's do 315 divided by 21. It's 15. X cubed divided by x squared is x. And if I divide these two, let's cancel out. All of this is over 4 minus 9x to the 10th. So y prime is equal to 21x squared, 4 minus 9x to the fourth. Now in here, I have negative 9x plus 15x. That combines into a 6x and then plus the 4. Over 4 minus 9x to the 10th. So I need to simplify this now. These two. All right, so watch. 21x squared with 6x plus 4 on the top. And you take away 4 from 10, your final answer will be with 4 minus 9x plus 6. And there you go. So that's an acceptable answer. Or look, they might get a little bit more pickier. They might want you to factor a 2 out from that again. And then multiply those 2 with the 21. So they may have the answer in this form. Okay, and I don't really know what form they would have it in until you insert your answers. But this is an answer also. All right, so my question is, did you all understand the rules? How I got to this point? The rest is simplifying the numerator by factoring GCF. And then just simplify. Any questions? Folks, don't sit quiet. This is your chance to ask questions. All right, so then let's look at our notes on 1.8. And that's section 1.8 on higher order derivatives. So if you see primes, that's the first derivative. If you see double primes, that's the second derivative. Okay, so you see f double prime, y double prime, or you'll see this notation, which also means the second derivative. Or if you wanted to do the third prime, 1, 2, 3, you'll see y triple prime, or you'll see it as d cubed y over dx cubed. So that's your third derivative. And if you wanted to do anything higher, you don't use primes anymore. You use numbers instead. F of 4 or y of 4, or d4y dx to the 4th. And this means the fourth derivative, and so forth. Okay, so what we're going to do here is we'll do the second derivatives. Okay, we won't do the third, we won't do the fourth. Okay, we'll just stick with the first and the second derivative. One of the applications that you would see in here with the higher order derivatives is that you will be given the distance formula. They'll ask you to find the velocity. Velocity is the first derivative. They may ask you to find the acceleration, which is a of t. It's the second derivative. Okay, so velocity is the first derivative. Acceleration is the second derivative. See, so that's an application of higher order derivatives. All right, so here is our first example. Let's see. I want us to do this on the whiteboard, okay? We can handle this. Y equals x squared minus 5. I'm sorry, minus 2 to the 5th power. And they're asking me to do the y prime and y double prime. Okay, so let me copy this on the whiteboard. Let's try it. Okay, so here is 1.8. Y equals x squared minus 2 to the 5th. Find y prime. And then I'll just say y double prime. Okay, so let's do these two. I want you to try it. So obviously you have to do the first prime first, and then from the result of the first prime, you prime it again will give you the double prime. Okay, so your first step would be is to do this, the y prime. Okay, go ahead. I'm waiting for you to do it, please. So what rule is it to differentiate?
Chain rule.
Chain rule, yes. Can you tell me what that chain rule is, please?
5x squared minus 2 to the 5th power minus 1 times the differentiated, which is just 2x.
Very good, very good. So if I simplify it, that will be 10x times x squared minus 2 to the 4. Okay, so this is our first derivative. Are you all good with that so far? Now let's do the second derivative. Okay, what rule would I apply to do the second derivative? We did one like this, the very first problem today, when we reviewed 1.7. Do you recall how we did that? What rule do you apply? What rules, I should say?
The product and chain.
Very good. So it's the derivative of 10x times x squared minus 2 to the 4th plus 10x times derivative of x squared minus 2 to the 4th. Derivative of 10x is 10 times x squared minus 2 to the 4th plus 10x. Let's do this derivative, and that's your chain rule. So can you tell me what this chain rule is, please? You tell me so I can write it, folks.
4x squared minus 2 to the 3rd power times 2x.
Very good. But I'm just going to write down the breakdown and then we'll do the results. So y double prime is 10 x squared minus 2 to the 4th plus 10x. Now look inside. Yes, you are getting the 2x from that. And then you're going to multiply by that 4, so that's an 8x with the x squared minus 2 to the 3rd. Okay, so y double prime is now 10 x squared minus 2 to the 4th plus 80x squared with x squared minus 2 to the 3rd. And now we have to factor, okay? Greatest common factor to simplify. See, so the derivative parts are really not that hard. It's just the simplifying parts that we just need to be careful, practice it, okay? It's not too bad. And if you look at it, there's a 10 here and an 80. So I've got 10 in common. And then I also have x squared minus 2 in both. You take the one with the least exponent. So your GCF is 10 x squared minus 2 to the 3rd. If I factor it from here, from the first term, I have x squared minus 2 to the first power left, because 4, if you divide by this one, the powers subtract, you get a 1. And if you divide this by GCF, you just have an 8x left. Okay, so one more, maybe a couple more steps. 10 x squared minus 2 to the third. And this just comes out to x squared plus 8x minus 2. And that's our final answer. Okay, so please make sure you don't give up, folks. You need to practice simplifying expressions. And a lot of these, as you've seen, are factoring parts, okay? You keep on factoring until you get to the final simplified answer. All right, so let's look at going back to the notes. Okay, we worked that out, and this is our final answer. Yes, I did. What did I do? Our answers don't match here. Let me see what I did wrong on that one. I apologize. We must have done something wrong. I didn't catch up to it.
The 80x squared in the third line from the bottom. Yeah, that one. You brought it down as just 8x.
Yeah. Yeah, I knew that was something that we were doing wrong, so that should be a square. So then this would be x squared plus 8x squared will be 9x squared and minus the 2. Yes. Thank you. All right. So that is the correct answer. Now, the other thing we have is this, okay? Let's look at this problem. I have a few more minutes left, so let's do this one real quick, the application problem, okay? I'm going to write this on the board and we'll try it together. So I'll give you the distance function, which is negative 10t squared plus 2t plus 5. The question would be is to find vt and at, okay? So this is a real simple problem. Okay, so here's your distance of an object traveling, okay? It's given as a function of time, s of t, as negative 10t squared plus 2t plus 5. Find the velocity, which is v of t, and acceleration. That's a sub t. Okay, so go ahead and you work this out. Tell me what your answers are. So remember, it shouldn't take you that long to do this. Remember, velocity is the first derivative. And that's just a simple power and a constant rule, so that should be negative 20t plus 2. Okay, so if this is with the unit of feet, and if t is seconds, then the velocity will have unit of feet per second. and acceleration is the second derivative. So you differentiate this, which gives you negative 20. And the unit for that will be feet per second squared because you're differentiating twice, okay, with respect to time. That's why it's second squared. So make sure when you're doing these applications, look for the units that they have given you in the problem, and you do give me the answers with the units, okay? So velocity is feet per second, acceleration will be feet per second squared. Let's look at another problem right here. Let's say y is 2 over 3x plus 1 to the fifth. Find d squared y dx squared. Second derivative. So obviously for you to get to the second, you need the first, okay? So do the first derivative. Now I'll give you a little help here, and I would rewrite this problem. I know a lot of you probably would want to do this as a quotient rule. But remember what I said. If the numerator is just a plain number, it's easier for it to rewrite it and then just apply the chain rule. Okay, so I'm going to leave it at this point. You try it. Do the first derivative and then the second derivative. Please. All right, so let's look at this problem. I don't have a lot of time left here, folks. And stop me if you don't understand it, okay? So this will be 2 times negative 5 times 3x plus 1 negative 5 minus 1 times 3x plus 1 on. So if I prime this, I get just a 3. Now look, I got 2 times negative 5 times 3. So that's negative 30. And then I have 3x plus 1 to the negative 6. Okay, so this is our first derivative. This is our dy dx. Now, I need the second derivative. So what rule would I apply to do the derivative of this again? Folks, are you still there?
Yes.
What rule would you apply to do this derivative now?
The chain and power.
Yes. So negative 30, same as the first one, times negative 6 times 3x plus 1 to the power of negative 6 minus 1 times 3x plus 1 prime. So the second derivative will be, again, if you prime this, it just gives you 3. Okay, so help me, folks. Negative 30 times negative 6 is what? 180, right? 180 times 3, is that 540? Am I
Yeah.
right?
That's correct.
With the 3x plus 1 to the negative 7. And you just rewrite that as 540 over 3x plus 1 to the 7th power. Okay, so again, see, you're not doing anything different when you're doing the second derivatives. You still are applying all of these rules that you learned in earlier sections. It's just you are differentiating it 2 times. All right, so I think I'm going to stop here. Remember your assignments. I had it written on the first page on the whiteboard in case you forget. February 7th, homework on sections 1, 7, 1/8 and quiz 4. And then February 10th, you have to do test 1 review and test 1. Okay, 10th is in the middle of the week, folks. That is, I believe it's Wednesday next week. Okay, so that's Wednesday next week. You have test 1 review and test 1 due. And all of these assignments are in My Math Lab. So as usual, if you go over this, you have any questions, read the book first, folks. Okay, read the textbook. You have the e-text in My Math Lab. Read that first. Look over all the notes, all the videos, everything that you have available, and then do your homework. Trust me, it does make a big difference. And also, I'm available. If you have any questions, please email me. Any questions about your answers, your gradings, take a screenshot. Email the picture as an attachment. Be very specific in terms of where that problem is. Is this homework or a quiz, and the number for that homework and the quiz. I'll look at it and I'll give you a grade. Enjoy your day, folks, your weekend. I'll talk to you all on Monday.
Thank you so much. Have a great day.
Thank you.
Thank you.
Thank you. Have a good day.
And thanks all.
Thank you. Bye.